Hi guys, I'm Engineer Hans Flores de la Cruz and welcome to our course Mechanics of Deformable Bodies. In this video, I will introduce to you first our course and we will be discussing the importance of this subject. To start with, let's discuss about the three fundamental areas of engineering mechanics. Those are statics, dynamics, and mechanics of material. So define muna natin sila kung sino sila. So statics deals with the equilibrium of bodies, that is, those that are either at rest or move with a constant velocity, while dynamics is concerned with the accelerated motion of bodies. And strength of materials, or which is also called mechanics of materials, deals with the internal effects and deformations that are caused by the applied loads. Okay. So, for sure, lahat tayo is, or lahat kayo is na-take na ninyo yung statics and then base sa experience, no? It deals primarily doon sa mga external loadings, no, in determining support reactions, or shall I say yung majority ng topic dito is about external forces which makes the system in equilibrium or at rest. While in dynamics, no, diyan is ang ina-analyze naman natin is still external forces, but yung external forces na yun is ina-analyze natin to determine what causes the body to move. So technically, both statics and dynamics are devoted primarily to the study of external effect upon rigid bodies, that is, bodies for which the change in shape or deformation can be neglected. Ibig sabihin, puro forces lang ang ini-analyze natin. We do not take into the account yung property ng material, yung magiging behavior ng material upon the action of forces. While doon sa mechanics of materials or mas kilala natin bilang strength of materials, dito we put into account na dun yung magiging behavior ng material, no? Kung mag-fail ba siya, kung masisira ba siya, okay? And to determine that property of material, ang ginagamit naman natin ditong forces is yung internal forces, yung mga forces na pumasok na sa member, no? Para masolve natin na rin yung deformation niya. Okay. So to better understand the relationship between these areas of engineering mechanics, let's take a look to this table. Okay? So since statics and dynamics seems to be the same, no? Ang pinagkaiba lang that statics is at rest and then dynamic is study of bodies in motion. So, pero the rest, almost the same na sila. So pagkasamahin natin sila dito sa figure or sa table, and then i-compare natin sila sa strength of materials para malaman natin kung ano yung difference nila and then similarities. Okay, so when it comes sa body, no, or dun sa materials involved kapag tayo nag-a-analyze ng mga problems, we assume that bodies under statics and dynamics as rigid bodies. So ibig sabihin nga nun that they are not subjected to deformation. While in strength of materials, we put into account na dun yung real property ng material, so which is deformable. Okay, next. The comparison between forces dito sa dalawang subject matter na to is that dito, mga external forces or external effect yung tinitignan natin, while sa strength of materials, internal forces as discussed before. And then, dito naman sa analysis, so paano ba mag-analyze ng mga problems related sa statics and dynamics, and then paano mag-analyze ng problems related sa strength of materials. So kung makikita mo dito that yung similarities nila is dalawa, no? That all subjects here requires free body diagram. Kasi nga naman yung free body diagram, ito yung nagpapasimplify no equations natin or nung analysis ng problem. And then, dapat dito is merong equations of equilibrium lalo na sa statics. Kasi nga, di ba, for the body to maintain its state at rest, di ba, that all equations of equilibrium dapat masatisfy, that all forces must be equated to zero, and then all moments must be equated to zero. Same doon sa strength of materials. No? Kailangan may free body diagram and then equations of equilibrium. Yun nga lang, merong madadagdag na mga deformation diagrams. So, sa future, i-discuss natin more about this deformation. And then, ano yung focus or main goal ng mga subject na to? When it comes to statics and dynamics, ang pinaka-goal natin dito is to identify the loads that acts on the body. Yun nga is yun to determine the support reaction, the force required to maintain equilibrium or to put the body in motion. So, puro force yung gusto natin ma-determine dito. While sa strength of materials, though kinukuha rin naman natin yung mga forces na yon, pero ang main goal natin dito is what? Ayan. Ang main goal natin dito is to determine actually the strength and rigidity of the body. No? Kung paano nagbe-behave yung material and then yung strength niya. Yun yung main goal natin dito. Okay. So, nabanggit natin class na internal forces yung involved when it comes sa subject nating strength of materials. So, first, why are the internal effects in an object important? Okay, so bakit sila mahalaga? So, let's check this figure. So, makikita nyo class, meron ditong arc bridge, no? No, yung arc bridge na yan is, ito yung bridge, no? Supported by an arc and then which is connected by steel cables. Okay. So, bakit mahalaga yung internal effect? Ngayon, kung titignan natin tong figure na to, is that itong slab na to, nung bridge, di ba, is siya yung main source ng weight which is carried by this arc. No? Yung weight niya at the same time pati yung mga dadaan dyan, mga sasakyan, vehicles will contribute doon sa weight which will be supported by this arc. So, eto yun. Ayan. So, that portion ng figure will induce a weight which is directed downward. Tama. Ngayon, para hindi mag-fail yung bridge na yan, so dapat yung downward force ma-counteract, which is ang magka-counter dyan is yung mga steel cables connected dun sa arc. And then since downward ang motion nito, so yung magiging resistance or reaction ng mga cables is upward. Okay? So kung makikita natin dito class is that meron tayong downward and then upward force. So ibig sabihin, yung body or yung mga cables dito is subjected to a what? Tensile forces. And then the tensile force is actually the internal force received no mga cables. And then bakit mahalagang malaman yung mga internal force na yun? Kasi kung hindi natin kayang ma-solve or ma-determine yung mga internal force na yun being carried by the cable, ano mangyayari? Possible hindi niya ma-carry to bridge and then will lead ito sa collapse. Tama ba? Now, kung hindi natin ma-determine or ma-analyze correctly yung mga internal forces doon sa system, possibly mag-collapse yung system. Okay? So, check rin natin tong next figure. So, dito nakikita natin is yung commonly nakikita natin sa building, column, and then girders, and then slab. So, ibig sabihin, kung makikita mo sa figure na to, etong slab na to is being supported by this column. So, alam naman natin, may bigat yan, no? Self-weight, and then yung mga loadings above that slab is being carried by this column. Okay? So, highlight natin. So, let's say ang portion na yan is being carried by column. So, ibig sabihin, since weight yan, so therefore, yung loadings niyan is directed downward. Okay? So, yung downward force na yan, dapat ma-resist yan ng mga column natin. So, para ma-resist yan downward force, edi dapat mag-react naman upward yung mga column. Okay. So, magre-react siyang upward. So, nakikita naman natin dito is that downward and then upward. So, ibig sabihin that a portion or the internal effect netong force system na to doon sa column natin, supporting column natin is compression. Kino-compress niya yung column. And then, once na hindi natin ma-take into account or ma-analyze correctly yung internal effect na yan, which is compression dun sa column. So, possible yan mag-lead sa failure. Okay, so magka-crash siya. Kasi nga, hindi naman natin na-analyze ng tama, no? Alam lang natin makuha yung mga forces, di ba? Yun kasi yung under statics, eh. Malaman mo yung mga forces, but hindi mo na take into account yung property ng material involved. So, nag-crash siya kasi hindi pala kaya ng material na yun na i-support yung ganong compressive force. So, to sum it up, no? To sum it up, so these are the reasons why internal effect in an object is important. So first is yung strength, no? Okay, so yung questions dito is the object strong enough to withstand the load that will be applied to it? Okay, will it break or fracture? Will it continue to perform properly under repeated loadings? So yun nga, so sabi ko nga, hindi lang naman sapat class na alam mo yung mga forces, magaling ka mag-solve ng forces. So dapat marunong ka rin mag-analyze, no, kung kaya bang i-resist nung material na gagamitin mo yung ganong amount ng force. Okay? Next, stiffness. Will the object deflect or deform so much that it cannot perform its intended function? So, dapat kasi, hindi kasi lahat ng material, though available, no, hindi lahat ng material is suitable, no, as a material to support some loading. So, dapat i-take into account rin natin kung malaki ba yung deflection niya. So mabilis ba siya mag-deform? Kasi nga, once na katulad ng malaking mataas ang deflection niya, so possibly hindi siya serviceable, no? Hindi siya makapag-serve ng tama. And then next, stability. Will the object suddenly bend or buckle off shape at some elevated load so that it can no longer continue to perform its function? So same lang yun, no? Kapag yung body na bigla mo siyang sinubject sa isang loading, no, na baka mabali or mag-fracture lang siya agad. So, failure agad yun. So, therefore, ibig sabihin, napakahalagang malaman natin yung mga internal effects doon sa body para ma-analyze natin kung kaya ba siyang i-carry nung material na gagamitin natin. Okay? So, as a summary doon, no? So, as engineers, ito napakahalaga ito. As engineers, we need to first, select proper material. Dapat marunong kang pumili, no? Katulad nung sa kanina, diba? Sa bridge, under siya ng tension, yung cable, and then sa column, under naman siya ng compression. So, hindi kasi sa lahat ng cases, the best gamitin yung steel, no? Hindi sa lahat ng cases, the best gamitin yung concrete. Kasi, meron silang kanya-kanyang specialty. So, para malaman natin yung proper selection ng material, dapat alam natin kung paano nagbe-behave yung material na yan. And then, after selection ng proper material, kailangan naman makapag-specify tayo ng correct dimension. Napakahalaga ng correct dimension, hindi naman kasi pwedeng sobrang liit. Kasi sobrang liit will lead to failure. Hindi rin pwedeng sobrang laki kasi hindi siya economical. So, yun yung goal natin as engineers na makapili ng tamang material na gagamitin at the same time specify yung correct dimension. And then once na makuha natin yung dalawang yan, so that will lead to an efficient structure or machine. Okay. Next. So ayun, na-discuss na natin yung kahalagahan ng internal effect or forces, no, sa isang system o sa isang material na ina-analyze. Ngayon, paano ba tayo makapag-extract ng mga internal forces na yon? Okay, so let's say for example, meron tayo ditong body. Okay, so let's say tube subjected to 4 arbitrary forces. P1, P2, P3, and then P4, no? Arbitrary, sabihin in any direction, basta bahala na. Ngayon, gusto natin ma-analyze kung ano ba yung effects or effect netong mga forces na to within doon sa, let's say dito sa portion na to, no? Gusto natin malaman ano ba yung epekto nito pag pinagsama-sama ko to doon sa isang body dito sa point na to. So, para malaman natin yung internal effect niya, so simple lang naman yung procedure dito. No, ikakat lang natin yung point na being analyzed. Ikat natin siya and then mapapalabas na natin yung mga internal forces. Take note that these forces, no, yung apat na to are external forces. Ibig sabihin externally nag-a-act siya dun sa system. Ibig sabihin naman ng internal, ibig sabihin yun yung nare-receive niya, no, sa loob. Okay, so ikat natin tong body na gusto nating i-analyze or ma-determine yung internal force sa kanya. So, upon cutting the section, ito yung lalabas. Okay. So, upon cutting the section, ito yan. Lalabas ngayon yung mga internal forces. And then since ang analysis natin is always 3D, so therefore, there are already 3 axes available. So, x-axis, y-axis, and then z-axis. So, sa lahat ng axis na yon, possible may mga forces na lalabas. Okay, take note, in general, there are 3 possible internal forces involved. Yung along the longitudinal and then yung dalawang shearing forces. So, itong along the longitudinal, since ito yung area being considered or analyzed natin. So, area, and then this one is the force. So, normal yung direction niya or normal or perpendicular siya dito sa area. Okay? Take note yung term na normal Since this is the area, so siya is perpendicular. So, siya is acting normal. While these two forces, Py and then Pc, sila naman is parallel doon sa area being considered. So, tinatawag naman sila as shearing forces. So, upon cutting a section, technically, in general, tatlong forces lagi yung lumalabas. Tatlong internal forces. And at the same time, about those 3 axes din, meron din doon lalabas na mga internal moments. No? Bakit? Kasi hindi rin naman natin sure na if these forces is acting directly doon sa centroid, no, nung body. Kasi kung hindi, therefore magkakaroon ng eccentricity, and that eccentricity will lead to moments. So yung may mga internal moments din yan. So mx, my, and then mc. So palagi yung class that in every section, cutting section, merong 6 no, internal reaction na meron. Ngayon, ano ba yung mga epekto neto or possible effects neto doon sa body natin, no? So, napalabas na natin yung mga internal forces, internal moments, ano yung possible effect ng mga yan sa body. Okay, so para mas ma-discuss natin siya further, punta tayo ngayon dito sa, so, pakita ko sa inyo kung ano yung maging effect nila. Okay, so let's first analyze yung tinatawag kong PX, yung normal. Okay. Normal. Tinatawag natin siyang normal since yung force P na yan, okay, yung force P Px na yan is normal or perpendicular dun sa area being considered. So let's say, ito yung kinat na nating section. So, ito yung area. And then, ito siya. Px. Okay, so the area is vertical, the force is horizontal, therefore normal or perpendicular. So mas commonly tinatawag siyang normal. So when it comes to normal forces, ano yung possible maging effect niya dun sa material natin or dun sa system? So kung titignan natin yung class, no? Let's say kunwari dito i-fix ko muna siya. So kapag ang isang body, no, yung tube na to is hinila natin, subjected siya sa isang normal force, ang mangyayari, it may end up elongating, di ba? Or that force tends to elongate yung bar natin. Let's say bar siya. So from initial length niya, mag-elongate pala siya due to the normal force involved. So actually, normal force na yan, merong two possible cases yan. No, it's either that the direction is away doon sa member being analyzed, or possible that the force is directed towards doon sa section or area being analyzed. So paano naman kung papasok naman siya? So kung papasok naman siya, ang tendency is that the member will shorten, iikli siya. Okay. So those two possible effects ay tinatawag natin tensile effect, and then this one is compression effect. Ibig sabihin, possibly mag-under tensile or ma-stretch yung member, or ma-compress or ma-shorten yung member upon the action of normal force. Okay, so yun lagi yung class. Kung basta normal force ang involved, ito yung possible effect naman niya. Okay. Next, paano naman kapag yung dalawa pang forces, which is yung etong mga forces na to na parallel naman sila sa area being considered. Ano naman yung effect nila? Okay. So this one is perpendicular. So what about naman sa P, Y, and P, say, which is shear ang tawag sa kanila, no? Shear ang tawag kapag ang direction niya relative sa area being considered is parallel. So let's say ito siya. So initially ito yung member. Okay. Tapos dito yung force PY. So yung PSA is perpendicular na siya sa paper. So hindi ko na siya papakita kasi same lang naman siya ng effect ng PY. So ano mangyayari sa body when it is subjected sa shearing force, let's say PY. So di-analyze natin. So i-fix natin siya sa isang side. Tapos apply natin ng shearing force. So ano mangyayari? So mangyayari dun class is ibabaguhin nung force na yun yung shape nung member. So dating horizontal yan. So ngayon, dahil sa shearing force na yan, so mababago niya yung shape. Okay? Gets ba? So binuhat pataas na bago niya yung shape. Yun yung maging effect niya. Or this is so-called shearing or sliding effect. Okay, pakitanda na. Dito, ang effect niya is either tensile or compression yung effect. No? Dito, kapag shear force ang involved, therefore, sliding or shearing din yung effect. Okay? Then, tapos na tayo sa mga forces. Doon naman tayo ngayon sa mga moments. So, dito, may tatlong moments pa rin, 'di ba, na involved or internal moments na nandito sa cutting section natin. So, ano yung magiging effect niya dun sa body? So, unahin ko tong about the longitudinal axis. Okay, kung ano yung magiging effect niya. So let's say ito siya. Yung moment x yun, di ba? Mx. So let's say ito yung tube. So di ba along or about the longitudinal axis siya pag ganito. Mx. So ano yung mangyayari? Let's say ito yung tube, no, yung ballpen ko. No, tapos paano yung moment pag ganito, di ba? Pag ganito yung moment. So anong gagawin niya? Ito-twist niya, di ba? Yung member. So tinatawag rin siya as twisting moment. Okay? Twisting moment kasi yung effect niya is twist, no? Or tinatawag rin siya as torque. Okay? So yung gagawin niya is ito-twist niya yung member. Hindi ko lang siguro siya ma-display ng maayos. Pero na-imagine niyo naman yun, di ba? Ito-twist niya. Let's say meron ako ditong line. So upon the action of that moment, so yung line na yan, magto-twist yan. So ganito yung mangyayari. So from initial na ganyan siya, yung line magiging ganito. No, kasi nga na-twist yung portion na to. Na-twist siya. So from that initial position, napunta siya dito. Na-twisting. Twist ang effect. So meron na tayong tatlong effects, possible effects. Tensile compression, magkasama yan, dalawang yan. Sliding or shearing. And then twisting effect. Okay? And then lastly, no, analyze na natin magkasabay yung MY and MC. Okay? So nasan ba sila? Check natin ulit sa figure. So ito yung MC, ito yung MY. So siguro mas maganda kung i-analyze ko naman yung MC lang. So sisilipin ko siya dito. So pag ganito, isa-side view ko naman yung ano. Okay. So isa-side view ko yung drawing ko pag ganyan. So diba ito yung longitudinal axis, tapos nandito yung y-axis, nandito yung x-axis, nandito yung z-axis. Tapos along the z-axis, merong moment, diba? Along the z-axis, sa axis na perpendicular sa paper, merong z moment. Z moment. So pag ganito yun, MC. Okay, so para sure ka, check mo ulit yung figure. Ayan o. So ito yung longitudinal axis. Tapos yung direction niya is pag ganito. So same doon dito sa side view na drawing ko. So kapag minoment ko siyang ganyan, ano ang gagawin niya sa body? So let's say, gawin ko ulit sa ballpen ko. So pag ganito yung moment, pag ganun, no? So ang gagawin niya is, it will tend to bend the member. So from the original horizontal position, possibly, i-bend niya yung member. Okay? I-bend niya. Okay, so from the term itself, bend, i-bend niya. So therefore, ang effect is bending. Okay, so therefore, itong dalawang moments na to, actually, bending rin tong isa. No, ang bend naman niya is pag ganito. Mahirap lang siya pakita kasi. So, pero anyways, ang tawag naman sa mga moments kapag bending ang effect niya, di bending moments. Okay? Gets po ba? So, balikan natin. Tensile or compression kapag normal. Kapag shear, sliding, and or shearing. Kapag naman the moment is a torque. Therefore, twist ang effect niya. And then finally, kapag naman mga bending moments sila, therefore, the effect is bending. Okay? Ngayon, dito naman tayo sa paggamit ng symbol. No, ano ba yung symbol na ginagamit kapag force? Anong symbol ginagamit kapag moment? Okay. So bago ko i-provide yung last slide natin, so, yun lang naman lang din yung summary no, i-discuss ko. So discuss ko na dito kung ano yung symbol. No? Kung makikita mo pala class, diba, yung mga symbol na ginamit natin sa mga forces is puro P. Tama ba? Ayan o. Lahat ng forces na makikita mo is puro P. So therefore, technically, kapag force ang pinag-uusapan, ang symbol na ginagamit natin is P, general. And then kapag moment ang pinag-uusapan, the symbol na ginagamit naman is yung first letter which is M. Pero dahil nga hindi lahat ng forces is pare-parehas ng effect at hindi lahat ng moment ay pare-parehas ng effect. So therefore, kailangan i-differentiate natin yung mga symbol na gagamitin para sa future problem solving natin. No, hindi ka malilito. Okay, so ano ba yung ginagamit na symbol kapag normal ang force? So kapag normal, ang symbol na ginagamit is P pa rin. Okay, take note kapag normal ang force, P pa rin siya. Alatay natin. Pero kapag naging shearing na yung effect niya, no, though actually pwede pa rin natin gamitin yung P kasi siya nga in general. Pero para ma-differentiate natin siya, no, para malaman natin na shear nga yung effect niya, ang gagamitin nating symbol is B. No? Okay, V. Next, sa moments. So, sa moment, dalawa rin yung possible effect, either twisting or bending. So, kailangan pag-ibahin rin natin yung symbol. So, ngayon, kapag ang moment ngayon sa isang system is ang effect niya is twisting moment, so imbis na M ang gagamitin natin yung initial netong twisting or ng torque. So, letter T. Imbis na M, T siya. And then dito sa bending moment, so siya yung magre-retain ng symbol na letter M. Okay? So, punta na tayo sa last slide. So, etong last slide is i-show niya lang naman yung previously discussed ko sa inyo. Yung mga effects, no? Summary ng mga effects. Okay? So, that is just provided para makita mo, no, ma-visualize mo rin. And then, ma-summarize yung mga diniscuss ko. Okay, so, yun lang naman yung introductory topic sa ating subject matter na strength of materials. So, sa next video, I will be discussing about the first topic, no, under this course, which is simple stresses. So, hanggang doon lang class. Thank you and God bless.